Hi everybody. Anybody who's not here for IDR, please take your conversation outside. Anybody who is here for IDR, please find a seat. All right, thanks. We do have one note taker, but I would like to kindly ask anyone else who's willing to take notes to please consider doing so. The Etherpad is a great way to do that, and it lets you contribute a little bit at a time. Also, I would very much appreciate if somebody would monitor the Jabber room and at least relay any questions or comments to the mic. Thanks. Okay. Thank you to everybody who has stuck it out here to the bitter end. This is the very last time you have to see the note well until the next IETF. So please continue to note it well. Yeah. Except for the interims. Yeah, good point. And it may be that some people just like to look at it in between those just because it makes them feel good. So we have an agenda for today. There's one speaker missing off the bottom of this because of skew between the ASCII and the PowerPoint. Sorry. But let's begin. Sorry. We'll get the clicker going here. I forgot about that. And then you can change your own slides. Yeah.
Hello. Hello, everyone. Good morning. Yes. I'm Wei Guohao from Huawei. Today I will talk about the updates for the draft of dissemination of flow specification rules for Layer 2 VPN. This is the history of this draft. In 19th IETF meeting, this draft was firstly presented, and have received some good comments. A new SAFE for Layer 2 VPN full spec application is not suggested. It should not be introduced a new SAFE. A second one is we should consider more scenarios like QQ, SNAP, etc. In the second version, we make revisions for the comments. CEFI, the CEFI 134 is redefined for the VPN flow specification rules rather than the old layer 3 VPN flow specification rules, and additional component types for QQ, SNAP, etc. Closest to 19-second IETF meeting, it is adopted as a working group draft. This is the updates since the first working group version draft. We and VLAN action and TPID actions, the two traffic actions. This is the VLAN action. In layer 2 VPN scenario, we can use flow spec to configure the policy for the access network. The VLAN should be support pop, push, swipe, and other operations. In the VLAN action, we support the pop, push, swipe, rewrite inner VLAN action, and out VLAN action. We also support mapping inner course action and outer course action. We also support TPID mapping action. Okay. Next step, we want to support redirect to MacVIF action, and we want to introduce the flow spec to be enforced to a specific interface or interfaces. Other comments? Okay, thank you.
Donald, are you presenting now?
So I'm Donald Eastlake with Huawei, and this is a presentation on distributing Trill link state using BGP. So there's similar reasons, I think, for wanting to distribute Trill link state as for ISIS and OSPF. In fact, Trill uses ISIS, but it uses it essentially at a different level. Doesn't normally interconnect, so to speak, with the layer 3 ISIS. SDN controller, a typical kind of example where you want to have the link state information available to some box that can be gotten to by BGP. There's the actual topology information, there's other capability information and so forth, and MAC address reachability information, since essentially Trill can be viewed as routing on MAC address or on the it has these nickname summaries for egress for MAC address or adjacency. So the idea is a new protocol ID for Trill. Certainly not a shortage, I believe, of numbers there. So one would be could be fine for Trill to identify the Trill link state. And for MAC addresses, a new network level reachability information type. These are 48-bit MAC addresses, which is what Trill wants to know about. Here's a MAC address descriptor. Trill MAC addresses are, really extended by a data label, which is commonly a 12-bit VLAN or 24-bit fine-grained label, which is a type of label very similar to a VLAN supported in Trill. Of course, the lengths of the label is a little different in that case. There's a whole bunch of sub-TLVs and things that are in Trill. They're defined in RFC 7176, Trill use of ISIS, and these are some of them. I think it's actually most all of them, actually. They're mostly sent as part of the router capabilities or multi-topology router capabilities, TLVs, or when it's talking about group address subscriptions, group either MAC or IP address subscriptions. There's the group address TLV, and there's sub-TLVs in there which specify the address or addresses, group addresses that are of interest to the node, the router that's advertising that information. There's a link attribute of MTU. Trill has facilities for measuring MTU and taking that into account, primarily for the purpose of making sure that ISIS will operate properly and that you don't use LSPs that are too big. Trill uses ether-typed LSPs, so you could have jumbo frame LSPs, 1.9K LSPs. You can do that in Trill, but you would want only do that if you were sure your links could accommodate such large packets. And there's, in this draft, a suggestion to allocate an additional bit currently reserved in the node flag bits to indicate that a particular Trill node is a layer 3 gateway. And I think that's about it. Are there any questions or comments or the like? So this was presented in the Trill working group earlier this week to a favorable response. So,
can I ask how many people have read the draft? Some. Can I ask if anyone is, well, let me just ask the positive question. Who is favorably disposed to adopt it? It's pretty much the same number of hands. Of course, we will take that question to the list. Would you please send the request to the list also, if you haven't already?
Sure. We'll either Weibo or I will post a message to the list.
Who's presenting this one? Is this Weibo?
It's Eric.
Hello. Good morning, everyone. Weibo from Huawei. This topic is about dissemination of flow specification rules for NVO3. Currently, flow spec BGP flow spec can be used to disseminate traffic filtering rules to remote peers. The typical use case is for the DDoS mitigation. The BGP flow spec currently can only be used in IP MPS layer 3 network and layer 2 VPN network. It can't be used in NVO3 network. This draft is to extend the BGP flow spec use case to let BGP flow spec used in NVO3 deployed in NVO3 network. This is the scenario. It is the typical scenario for DDoS mitigation. The second scenario is for traffic engineering, traffic steering. Yeah. If the MPS network is used to as the DCI network between two ML3 network to ensure the traffic, the quality of the DCI network at the DCI PE device. Flow spec can be used to divert traffic to different TE tunnel based on different policy. This is the requirements summary for the BGP flow spec for ML3 network. The first one is the match part should include inner layer 2, layer 3 header and outer layer, layer 2 and layer 3 header information and ML3 header. The traffic filtering actions supposed to redirect to TE tunnel or ML3 tunnel. This is a flow spec extension. Two new component types for ML3 header are introduced. One is VIN ID to identify each tenant. It is a 24-bit tenant identification. The second type is the ML3 protocol type. And the third one, we want to introduce a layer flag. Yeah, because ML3 is an overlay technology, which the filtering, traffic filtering rules can be based on outer layer or inner layer. So we want to introduce a layer flag to indicate the filtering rules is based on outer layer or inner layer. Yeah. We introduce the layer flag in traffic action. Yeah, once this once the layer flag bit is set, the corresponding filtering rules will be applied on the ML3 inner layer. If not set, the corresponding filtering rules will be applied on the ML3 outer layer. But maybe there are other solutions for the layer flag. I also want to solicit suggestions from the community about the layer flag. Okay. Any questions?
Any questions from the floor? Okay, thank you very much, Wika. Eric, thank you. I'll run it.
Hi, this is Eric. I was going to present BGP flow specs extension for routing policy distribution. Okay, let's go. You all know from times to for different kinds of reason, providers going to change its traffic paths, entrance, exit, and for example, the reason could be link congestion or overload, especially in holidays, or just because of the transmission quality is not good, packet delay, loss increase, or just because of the corrupted packet increased, or even just the money issue, just we choose the lower price. And this one is one real requirement for my customer. I was going to simple explain here. So as here, my customer's AS is ISP100, and there's one PE device which is hope to access the prefix 1 in different ISP. And the requirement is for the reason before we said he hope the traffic exit through this star link, through L3 link. And for explain, this is or EGP peering between this IGW and different transit provider. So this is for outbound traffic for my customer. And next slide is, this is opposite scenario for inbound traffic. So for this prefix 2, which P2 device was hoped to access, my customer was hoping the traffic can enter through this link 3 between ISP10 and IGW2. And his requirement is not only to just transfer the traffic from previously, before, for example, L2 to L3, to transfer from L2, but his requirement is we just didn't want my traffic just to get out of the link. I want the traffic to enter through some designated link. This is his requirement. Okay. Next is this is from his maintaining experience. He hoped us to hope the solution can satisfy those requirements. First of all, is he do not want to configure the policy on device based, because he would think this is too big burden, and it's easy to make a mistake. And the other one is since this kind of traffic adjustment is frequently happen during a day for different kinds of reasons, but he hope we can provide some dynamic provisioning mechanism instead of static configure 1. And of course, this solution can be safe to undo or roll back without any damage. And of course, as time going, this is a policy things is going to complex to maintain. So he hope we can easily and with some reasonable complexity. And of course, because of the lots of policy was going to involve, so he hoped our mechanism or solution was with high performance with a very small delay. And the battery is backward compatible with the last software upgrade. Okay, this is
I see there's a question waiting. Do you want to take questions as we go, or do you want to hold them for the end?
How about hold the end? I have three more slides. Is that okay? Thank you. Okay. This is the proposed solution, and we're calling this routine policy distribution. The key point is we're taking effect on the control plane instead of forwarding plane, and the impact decision is executed on the remote site. And we are using BGP flow spec as a protocol to carry these things. We introduce one new bit, we call it R bit, for example, to add in the traffic action community. If this bit was set, it means we have more information carried in another new attribute. This is the attribute we're talking about. It is a new policy attribute. This is a structure to primarily two parts. One is the match field, the other is action field. For the match type, we're going to two value for positive match or negative match. Positive match means when you match, you have to take some action, and the negative means if you match, you do not take some action. And the action part is like this. This is some sub-TLV type. I was going to explain the scenario how to solve in our proposed solution. The next slide. So here for the outbound traffic control, match type is permit, and we use the subtype here for IPv4 neighbor. We're going to precisely designate which link we're going to outbound. So the action type is route preference. So the AGW2 maybe prefer the L3 link, the route. So the traffic can get out from that link. And in the inbound traffic scenario, the match type is deny, and the sub TLV is for the source and peer address. So designate one specific link. and the action type is prepend current AS, for example, 5 times. So that means when I advertise the route to the remote site, I was going to, I was not going to prepend AS, but the other interface will prepend. So when the route selection, my peer will going to prefer my entrance. So that's the idea behind this. I hope you all get my idea.
Rudiger, did you want to go ahead and ask your question?
Yes. Well, okay. The question was in the context you were saying you have a customer that has this requirement.
Yes.
And my stupid question was, well, okay, and you were talking about 2 ASs and you wanted to control the traffic between. The simple question would have been, which of the ASs does your customer control?
I'm sorry, I didn't get the last word. What was that?
Well, okay. Which of the ASs does your customer control, like operate, configure the routers?
See, in this scenario, we are talking about only intra-AS control. My customer policy controller here only can control the device he owned. So only intra-AS, no inter.
So ISP100 is your customer?
Yeah, ISP100 customer. And the second scenario here. AC?
AC Lindum, Cisco Systems. So it's not clear. First of all, you know that egress peer engineering is a controller-based solution that does exactly the same thing. The only implication is you have to use segment routing, right?
Actually, we're talking about the pure IP network.
Pure IP, okay.
Yes.
So what this basically is it's a BGP reuse of flow spec to do policy-based routing, just like the ACLs that are
PBR-based.
Yeah. Just it's putting it into the piggybacking it on the flow spec. Okay, I see what it says. So couldn't you just control that with MED? I don't know.
Manual?
Okay, more than that. I'll let John comment.
Okay. Yes. It's also possible if we do this, change different attribute. I will think that.
So John Scudder, but before I make my comment, I saw you had one last slide contrasting this to conventional policy. Did you want to talk to that one?
This one?
No, you keep going to the end of your deck. Keep going. Yeah. Is that your last slide, and do you want to say anything about it before I ask my question?
Okay, you let me finish first?
Yeah.
Okay. This is people maybe ask the primary concern is why not manual configuration? Because based on the maintained experience, my customer was hate to do these things because in the long run there's too much policy on device base. They are not going to easy to maintain and very easy to mistake. And one more thing is this manually configured policy is going to change on a daily basis, so they cannot take it. It's not easy for them. Okay, this is one slide's meaning. So, okay, thank you. Okay, actually I have 2 more. Okay, so people are going to ask, okay, current PBR-based flow spec already can do similar things. Why new things? So here's an example. Actually, we collect from our customer. He was going to say, okay, I was going to explain. See from the CE traffic, he's going to visit IP5, but my customer's domains inside here. He has no way. He can do PBR-based flow spec to redirect the traffic from L2 to L1. This is legend, sir. L2 to L1, but actually the CE's traffic is going to take this way down, so no way to affect the device outside his control. So this is the meaning here. And next slide is. We all know the PBR-based flow spec is changing the forwarding decision, but sometimes it may be causing forwarding loop. For example, the CE here, he is going to visit the prefix 1, and okay, original path is for M2. Yes, I can change the redirect to M3, but the M3 actually was preferred the next hop for IGW2, so loop can happen here. So that's the reason why we propose the solution. I'm done, John.
Thanks. John Scudder, speaking as a working group member in case anyone cares. So flow spec historically, up until this moment, has been about affecting the forwarding plane. It's about programming forwarding plane filters and so on.
Yeah.
You're proposing to use it to affect the control plane.
Yes.
Now, you've made an argument that says, yep, the control plane is the only way that I can affect the forwarding plane on my peer. So it's an interesting argument, well played. But I think it's a bit of a stretch. And the second point is, standardizing policy turns out to be pretty hard. We already have an effort underway to do that with the Yang model. We have an effort inside the IETF that exactly has taken several of your requirements and, in particular the timeliness requirement, like I need to be able to change this data quickly. That one's called I2RS. To me, it seems like you should be pursuing those and either making them do what you want, using them if they do what you want, complaining if they don't do what you want, rather than trying to fit policy into sort of an unnatural container for it, which is flow spec. And in particular, I really would hate to see the working group trying to standardize two different ways of configuring policy at the same time when it turns out that we've always had a hard time doing even one.
Okay, thanks, John. My answer was what you said about Yang. Yeah, I didn't. First of all, I didn't say this is the only way we can do that. Sorry. Shit. We didn't say this is the only one we can do that. But yes, I2S or Yang may be the other path. Okay, maybe I do not want to say too much about this. Thank you. AC?
1 minute.
Sorry.
AC, I will try to, Robin Huawei, I try to explain opinion about this policy. In fact, we also, thanks to Jeff and other people, they propose a concern about the policy work because now a lot of pieces of work is being done in the IETF or the different working group. So they try to how to organize this work together. So, but I think that in fact that we truly discuss with customers, they have the opinion to use some this the dynamic and this the control protocol to deploy the policy. So from our point of view, we define this one. So this because now that because that the policy is too flexible, so that is a little difficult to master. So that we define this the BGP flow spec for the routing policy. The method we discuss with customer, we get the feedback, so that we try to set up this work from the beginning. So this may be applicable. Yeah, that's my point.
Okay. Thanks. Thanks, Robin, Eric. AC Lindum. I think one thing you need to do is document your assumptions as to who's has administrative control of the ASs. And I think, in this situation, you'd want the policy controller to also be getting all the routes too. So, because if it's just blindly setting policies, it's got to be co-resident with the route reflector or something. It's got to know whether there's a path before it does making sure the path is valid. You should just document that so it just doesn't, if policy-based routing, the way it typically is, and you just configure it on a router, it's intra-domain, it's under a single, and somebody says, okay, I don't want to use any of these complicated solutions like multi-topology routing or anything like this. I just want to force this type of traffic this way. Whereas in this case, it's external, where you're under, presumably both AS is under a different administrative domain. So if you're doing that, at a minimum, the policy controller has to be getting the paths and know the policies that it's setting are in fact reachable, right?
Actually, you lost me, I see. Can you put that on the list? Actually,
Yes, I can. I will. I'll do that. Yeah. I just said the policy controller needs to only set these flow specs for reachable destinations. So it has to have that, the controller has to have that information, which is an assumption for the egress peer engineering way of solving this problem with segment routing.
Short words, AC, you lost me again. Sorry.
You're going too far. One more thing.
If you didn't understand me, you sure aren't going to understand Jeff.
Let's try.
I missed that one.
Don't put it in minutes. He said if you
What can I say after that? Jeff Haas. No. So we have discussed that I do have concerns.
Yes.
No, so I'll repeat at least some of these things that have been mentioned to you for IDR, but many of them have already been covered. I do share John's opinion that FlowSpec is an awkward container.
Okay.
I do also have the concern that FlowSpec has implicit rule ordering for its NLRI.
Yes.
And I don't think that is probably a natural fit for this as well. I also have concern that BGP being used to distribute this, even if you took care of this in a different format, different NLRI, BGP is used to send this to many things. It's not really a good point-to-point distribution to send it from one router to the router you're looking to influence. It would be better for a set of routers. And if you're using your route reflector infrastructure to send it to many routers in the network, you're causing potentially those routers to carry information they don't care about. So that's a concern as well. My suggestion, this was something we already talked about, is there is many types of policy work currently going on in IETF. Some of it's happening here. Some of it's happening RTG, WG. ITRS also has pieces. My suggestion to you is join that to make sure that your policy for your customer can be represented in the model that comes from this. I also suggest joining work in I2RS, specifically for signaling this from one router to another. And if you don't believe I2RS is the right signaling method, as a distribution mechanism, pursue that potentially as a separate item. I do still think that the modeling work probably belongs in Yang.
Okay, Jeff, I would also hope you can put that in list also. So
I will do so.
I can get all your point.
Okay, regarding Jeff's comment, I want one more information. In fact, for us, we also proposed our Yang model for the route policy in the RTG working group. So definitely we will coordinate this work. Okay, yeah, thanks.
So comments, also suggestions, welcomed to help me refine. Thank you.
This is Genji from Huawei. I'm going to present label information for BGP FlowSpec. FlowSpec is an N-tuple consisting of several matching criteria that can be applied to IP traffic. And a FlowSpec role can be mapped to a label. And in MPLS network, label-based matching is more efficient. On the other hand, IFC 5575 defines a requirement for traffic statics per flow spec role. The flow spec role could use a label bound with the best match unicast route for the destination prefix embedded in the flow spec role. If two or more flow spec roles have the same best match routes, they would be mapped to the same label. So the granularity should be improved based on flow spec role rather than the destination prefix. This shows how label information used in the for the flow BGP flow spec. Assume a flow spec tunnel need from IP1 to IP2 needed to be established, and the flow spec role is injected in P2. Then P2 distribute the flow spec role bound with label 300 to SBR2. SBR2 distribute the flow spec role with label 200 to SBR1. And SBR1 distributes flow spec role with label 100 to PE1. When PE1 receive traffic from IP1 to IP2, the packet will be forwarded based on labels. At the same time, the corresponding actions will be enforced. The one way to associate flow spec role with label is to directly add a label subcomponent into flow spec NLRI in order to indicate the separation between a flow filter field and a label field. Separated needs to be defined. The second way to associate flow spec role with the label is using IETF93-IDR-201507. And each flow spec role is associated with label mapping TLV. The prefix field in the label mapping TLV need to use dummy prefix. We are wondering which way is better. I'm here to solicit your comments and suggestions. Thank you.
Thank you very much. Any comments on which way might be better? The existing way with flow spec and a combination of 3107 for Yang-Chi?
Jeff, I have not read your internet draft in detail, so I apologize if I mischaracterize some of this. The redirect to IP flow spec draft that is, within the working group already does cover the behavior of being able to redirect traffic to specific next hops. It's easy to read the draft and suppose that it only is meant for hop by hop forwarding. The intention of the authors is that this next hop may be not directly connected, may be far away in the network, and that the device that is installing the flow spec filter may need to tunnel it. Tunnels may, in some cases, include 3107 tunneling as well. Our request is, if you think that a 3107 style label for redirecting things should be explicitly part of the signaling for something like redirect IP. My request is take a look and see how your proposal would potentially impact or change the one that we have made for redirect to IP. And I will make sure to copy my response to the mailing list so that you can follow up at your leisure.
Okay, thank you.
He's going to send his response to the mail list so you can respond to him about the idea. Thank you.
Hello, everyone. Masim from Cisco Systems. This one. So I am going to talk about flow spec Yang model. Next slide, please.
There's an advance.
Okay, so I'm going to cover following topics. I'm going to talk about little background of the draft. Then I will talk about the configuration and state model for flow specification. And in the end, I will talk about the possible changes which is expected in the next version of the draft. So this draft has a little background. The draft was submitted in routing working group in March this year. We thought that most of the work has been done for BGP flow specification. So we resubmitted the draft in IDR working group after taking care of a lot of configuration and state parameters changes and filled up some of the gaps which were lacking in the first initial version of the draft. So here I'm going to talk about the overview of the Yang model. So essentially, what we are trying to cover is configuration and state model only. We haven't covered the RPC and notification as part of this model, essentially because typically RPC and notification are part of the vendor-specific extensions. And so we have focused currently on the configuration state data only. The flow spec rule as defined in this model is based on as defined in RFC 5075. For state information, it models route information and flow counters. So this draft is compliant by RFC 6087. What does that mean? That essentially means that the draft has been formatted based on the suggestion given in RFC 6087, and that also means that the model is fully extractable from the draft, and it compiles without any warning. Also, any vendor-specific extension can be added to the model itself. So to describe the model, essentially there is a top-level flow spec container. The flow spec container contains a config container and the state container. So the config container contains the configuration data, and state container contains the state-specific parameters. So flow spec config container contains a set of policies, and each policy contains a set of flow spec rules. And at the same time, flow spec state container contains a flow spec RIP information, which contains the route information for the flow spec, and it contains the flow spec statistics as a counters, which is per flow spec rule counters. Flow spec RIP maintains flow spec routes, and flow spec statistics maintain a set of counters. Okay, so this is an overview of the model where you can see that in this tree structure, you can see that there's a flow spec top level container. Then we have a config container which is read write, and then we have a state container which is read only. A config container contains a set of policies, and each policy contains a set of rules. State container contains a RIP container, and the stats container, RIP container contains set of routes, and stats container contains a set of counters. So in the config container, a policy is referred by a name. Each policy is associated with a VRF and the address family. A flow spec rule, each policy contains a set of flow spec rules, and each flow spec rule is again referred by a name, contains a set of components and actions. Now, components are referred by the type, and we support all the types supported in RFC 5075, and we have a set of action. Action is referred by type. Currently, we are supporting rate limiting, redirect, and traffic remarking. Okay, so for configuration data, you can see that in this tree structure, there's a set of policies associated with the VRF name and address family. Then we have a set of rules associated with contains a set of components, and each component is referred by a type, and then we have a list of component types. Similarly, for the actions, we have a set of actions referred by action type, And as explained, we support 3 actions right now. So flow spec state data contains route information and flow counters. And now flow spec route information is contained in the RIP container and contains a generic as well as protocol specific parameters. Now flow spec rules are part of the protocol specific parameters data container, and all the components and actions are part of the protocol specific data. Flow spec statistics contain flow counters, which is per VRF per address family, and there's a set of flow spec rules, and each rule will contain its own counters. The counters which we support is packet bytes, number of packets, number of bytes, then drop packets count and drop bytes count. So this is the structure actually for the RIP information. A RIP contains a list of flow spec routes. Each flow spec route contains a protocol specific attributes and protocol agnostic attributes. Component actions are part of the protocol specific attributes. Similarly, in the next slide, I will show you. For the flow spec state data, we have flow spec statistics as a container contains a list of flow spec stats. Each flow spec stats entry contains a VRF name and address family. For each VRF name and address family combination, we have set of rules, and each rule contains a list of components, a list of action, and set of counters. Okay, so what is the possible change in the next version? We plan to support V6 parameters. We plan to support other draft in the flow specification, and based on review commands, we plan to take care of those. Any questions?
Jeff Haas, I think you did a very nice, clean job of your configuration. So, congratulations on that.
Thank you.
I will be sending some specific comments about maintenance, including separating some of the stuff for IANA registries rather than inside the document, because otherwise you can't maintain the code points separately. Mm-hmm. 2 specific comments, one to you, one to the chairs. The first one is, for the operational state, some vendors actually have the counters showing up as part of their existing firewall reporting mechanisms. So I'm not sure exactly how well that will align with what you have in your table here. If you're doing a fresh implementation, this may make sense, but in terms of existing implementations, it may not be a good match.
Yeah, I mean, as far as the flow specification is concerned, this looks pretty logical to me. If, different vendors have different existing implementation, many times, in the Yang model, we have to map it actually, and this is the fact. This is the fact not only for flow specification, but other Yang models also. And no flow Yang model will actually fit as it is for all the vendors. So people have to map it. They have to maintain some kind of layering to maintain it, and that is a fact actually.
Right. The main reason to make the observation is that for several of those vendors, it's the case that the firewall is implementing the flow spec, and if you have any intersecting rules that are in the firewall that are not covered by the flow spec filter, packets are still being counted in the same buckets, and it's not possible to distinguish them. So I think not so much that it can't be mapped, but I think that it will never be clean in such circumstances. So it may be misleading operational state.
Mm-hmm. Yeah, those are interesting comments. Actually, as far as our implementation is concerned, we have a firewall rules, and after firewall rules, we specifically configure flow spec rules. So anything which passes the firewall hits the flow spec rules, and that is the order we maintain.
Right.
But yeah, obviously, many vendors will have their own implementation, and so you have to struggle a little bit to handle all this.
So the question partially for you, partially for the chairs. This is actually a nice model of FlowSpec, but it's written effectively as a service model. It's a way of saying, here's what FlowSpec is capable of supporting in terms of firewalling behaviors. So with that respect, it's good. BGP might be a consumer of the state. Potentially, an individual router might be a consumer of the state. We have to figure out which of these scenarios we're specifically servicing, and how does this interact with other efforts in the IETF to do filters that are firewall-like. So I2NSF, as an example, is a potential consumer of this, or potentially would have input on this as a service model. Again, realizing that this is targeted towards an existing protocol mechanism. And the second question, though, for the chairs is, as we do our modeling work for BGP, this could be perceived as a input to the BGP Yang model as one way of configuring some of the stuff, but this is closer to an adrib-in type configuration. You're actually putting state into the system rather than configuring the protocol mechanism. There's not a clean fit in the IETF modeling stuff right now for this. So I'm going to suggest that there's going to be some level of coordination that everybody involved will need to do to figure out where this fits into the architecture. So please, as chairs, raise this with the architecture team.
So Jeff, let me go back. Let me repeat it back in two ways. You're saying that this is a good model for the adrib-in, which is missing from the current BGP Yang model. I hope you will note that and pass that back to other co-authors on this that I know are at Google. The first question, are you saying this isn't a good model for filters, or good? I wasn't quite sure after I finished all parsing.
So it's a good filter for filters that fit the FlowSpec use case and the FlowSpec protocol distribution mechanism.
Okay, so it's a good model for the things that fit the FlowSpec use case and the FlowSpec model, but not for other things.
Yeah, so the question being, FlowSpec was invented specifically because it was a way to allow distribution of Juniper's firewall rules for some specific cases into BGP. So it's FlowSpec is less a firewall language, it's more of a serialization format that allow BGP to pick this up. As written, this is one part could be used for, here's how you actually put this stuff in there. Here's a way to represent your static routes, your adrib-in, each of those cases. But it also sort of looks like it's designed to be able to be used as sending these filters directly to a router for local installation with no BGP necessarily being involved. That's actually an interesting case. You could even say it's an I2S type thing. This is your, you can do this through BGP, or you can have it through Yang. The point being is that if you're going to take that use case into account, other pieces of IETF are going to be doing firewalling work. This is in that context, a way of doing firewalling work rather than a control plane protocol Yang model.
Right. So this might be something that if the I2NSF work has, they might take a look at this model. I will pass it on to the I2NSF as part of the coordination work. Thank you.
Right. On that, yeah, I would like to put one comment that we thought that it is important that we cover specifically for flow specification, which will cover all the flow specification current model drafts and the future draft, and will focus on that rather than a very specific firewall model. And so that is the reason we focus this as part of the document.
Right. And if your intention is to try to make this just the interface for BGP to use, I may either be misreading it or some additional clarification could go in. So a tightening of the focusing would mean that it's applicable only to IDR, as an example. But it is actually an interesting thing for other work.
Right. I had interpreted your comment kind of the other way around, which is this is applicable to IDR, but possibly it could be generalized to be more broadly useful, which would be goodness if we can do that.
Right, but I'm interpreting the draft in the sort of perhaps not thorough enough reading of it that it can be used for both purposes. this is actually a side point. The IDR should be aware, if people are not necessarily paying attention, that the IGP groups are actually doing flow spec redistribution within their protocols. The OSPF group has actually adopted this already. I had not been previously aware of that, and a similar draft is actually present in ISIS. So our technology is getting used in other places in contexts that I personally find a little weird, but I'm trying to communicate with the authors to understand their use case better.
The IGP groups do all kinds of weird things.
Thank you. Any other comments?
Realme Huawei, I just small pieces of the suggestion, because according to my understanding, the draft not only the configuration data but also the state data, right?
Right.
Yeah. So I think maybe the name should not use that the young configure. I mean, so that is a direct young change the name, because the name is the CFG. Yeah.
Okay. I think that is being the convention being followed, right? So we just follow that convention. In other, either we say CFG or we say model, that is the convention being used.
Okay.
So if we replace CFG, then we say model, or we say Yang model or something.
Okay, so that maybe.
Yeah, this is a typical convention, yeah.
Okay, it depends on you, because at the beginning, we propose some of the draft at the beginning with the CFG as that one, but later a lot of draft removed.
I suppose the name was actually modified later on based on some of the comments we got from routing working group and all. And we can change it again, but typically this is the norm that either we use CFG or we use model as a word. So we have to choose one of those.
Okay. Okay.
Any other?
We were from Huawei. This topic is about BGP flow spec afterbound route filter. Currently, BGP flow spec can be used to propagate flow specification rules to remote PE dynamically. Because BGP is a push model, so the routes will be propagated to all PEs indiscriminately. No matter this, the receiving PE needs these routes or think the routes is unnecessary. OIF is a BGP pull model mechanism. The receiving PE can use OIF to request the necessary routes on demand. This view is the burden of the receiving PE. In BGP flow spec scenario, the receiving PE also want to use the OIF mechanism to ease the burden of the receiving PE. There are two motivations. The second one is network security policies. SBR filters traffic from adjacent edges to reduce traffic. The second one is flow spec specific capability negotiation. It used to select from all types of OIFs, so just the ones selected. This is the scenario. The flow spec policy in this figure, the flow spec policy will be used on SBR1. SBR4 doesn't need the flow spec policy. So SBR4 can use OF mechanism to filter the flow spec rules. SBR4 send the OF message to SBR3. I don't need the flow spec rules. Later, SBR3 will not send the flow spec rules to SBR4. This is the protocol extensions. Which includes the RD and RD action match field and other blah blah fields. This is the protocol extensions. Filtering includes these filter types. Next step, we will describe the regulation about how flow spec OF entries filter the flow spec rule more clearly. We also want to solicit more discussion on the mailing list. Okay, other questions?
Any further comments?
Jeff has, and I have made these comments to the authors directly in more explicit form, but I'll leave this to the one-sentence version here. ORFs for flow spec are not a good idea.
Would you like to elaborate on your reasons? Okay.
You said.
Okay, Robin Huawei, I like the straightforward. We will try to that either take his opinion into account to refine this idea. Okay.
Okay, we can discuss further on the mailing list. Okay, thanks.
Hello everyone, I'm Sandy from ZTE. It's my presentation for upstream design label collision solution. At first, let me see an example. This example is simple. PE1 and PE2 send different MVPN flow to PE3, but they use the same MP2MP tunnel to send the different flow. So PE3 will be confused because the inner label and outer label all the same. So PE3 will not distinguish the two different flows. Because in present network, L3VPN was used for many years, and the network is developing. The MVPN and the DC will consume a great number of upstream assigned labels for inner label or outer label. So the label space is reserved on every PE. We can configure it, but the space if we reserved is too large, many labels will be wasted. If we allocate it very small, and some piece will use up all its labels. So network administrator will adjust the label space. But the work is too hard because the network is is not foreseeable, and we cannot know what will happen tomorrow. So it's a solution for the upstream assigned label collision solution. Each upstream PE advertises routes with the time step attribute. When downstream PEs finds that there are two upstream PEs advertise routes with a same upstream assigned label, the downstream PEs will choose the routes with the same principal. So all the downstream PE will choose one, the same one. All the PEs include upstream and downstream PEs will receive the routes. So also the upstream PEs that advertise routes with the later time step will adjust. He can adjust the label. And also it's a tie break because the time step may be same from different PE. So we can use the IP address of upstream PEs to tie break the choice. Someone may ask why we use time step. We may use local preference, MED, cost, and so on. Because the time step will mark the origination time of the routes. The routes which have been originated early should have more priority. The method will improve the network stability. Oh, it's all the solution. Comments welcome.
Me? Rafał Szarecki. Why not use router ID, which is commonly used tiebreaker, and it's absolutely deterministic. With the time, if you have time sync across the network, fine. The areas is areas. But then if new node comes in or somebody don't have the time synchronization, then you can have again churn, unexpected, because the new router will advertise earlier time because of misconfiguration or whatever, and then just make it simple. You just need the simple tiebreaker, right?
Okay.
Thanks.
Okay.
Robin from Huawei. Can you go to the previous slides? That's the picture.
This?
Yeah, this one. In fact, I little doubt that you means that PE will send the multicast traffic through a P2MP tree to the PE3, and the PE2 will use another P2MP tunnel send the traffic to PE3, right?
Yes. You mentioned P2MP. As we all know, we can use MP2MP tunnel.
Yeah, I agree with this one. Just simplify the question that you mean the two P2MP tunnel that the traffic is sent through the P1 to P3, another P2 P3, right? Yeah, okay.
You mentioned one station. You mentioned one thing. PE1 and PE3 use two different P2MP tunnel to transfer the flow to P3.
Okay, so that's my question. Why is there the label confliction? Because according to my understanding about this, the MVP draft, that the label space is context-based, that the context-based label is related with the P2MP tunnel because they are two different the P2MP tunnel, so the label space should be different. Why is there the label confliction?
Yes, you said it's simplest thing in the MVPN. As we all know, PE1 and P3 can use different P tunnel to transfer the MVPN flow to P3, as you mentioned. But PE1 and PE2 can use the same P tunnel to transfer the MVPN flow to P3. MP2MP tunnel
So I'd just like to mention that if I understood Robin's point correctly, that was also the point that Eric Rosen made he sent an email to the IDR list and to you, I think, on July 20. And I think he was making pretty much the same point about using the context. And I didn't see a reply from you to Eric yet, but I would recommend you read his email and reply to that.
I replied to them this morning.
Oh, okay. Did not see that yet. Thank you.
Okay, I will also check the mailing list. Okay.
Okay.
Yeah, basically in MPLS, we just decided that a multi-point to multi-point was too hard to manage the label distribution unless we want to go to an SDN solution.
Yeah, and this was going to be my second point, which was this work is probably mostly in the MPLS area. And so I'm sorry we did not catch that before and suggest that you present to them, but at least you should send your document to the MPLS mailing list as well so that they can discuss it.
Okay.
Any further discussion? George?
Well, they can bring it to MPLS, but it might be received as a dead horse. Or you can send it to Beth as well.
Yeah, I mean, I don't want to just like bounce it around. I just mean that's where the expertise is to comment on it. Most
actually, the best expertise is already commenting as far as I'm concerned. Rosen.
Fair enough. Any further comments, questions? If not, we are concluded. Thank you very much, everybody, for sticking through to the end. Hope to see many of you in Yokohama and at our next interim, whenever that may be. Thanks. Enjoy the rest of your day. Safe travels.